Chapter 3, Examples and Problems. Example 3.1. Using Ohm's law formula, verify that the current through the 10 ohm resistor increases when the voltage is increased. So we are going to keep the resistance at 10 ohms, and we are going to vary the voltage to see the mathematical impact it has on the current. So this is the formula when we want to solve for current. So the voltage is 5, the resistance is 10, so we get 0.5 amps. Now we're going to increase the voltage to 10 volts. So current is voltage divided by resistance. So now voltage is 10 and resistance is 10. So we have 1 amp. So what happened here? So the voltage doubled, so did the current. So we can conclude that if the voltage doubles, then the current doubles as well. Now we have the case in which we have the voltage at 20 volts. Now the current is going to be 2 amps. Yes, we can calculate it like this, but we can also say that since the voltage increased 3 times, the current increased 3 times as well. We're going to move to example 3.2, and here we're going to solve for voltage using Ohm's law. So what is the voltage across this resistor right here when the current is 2 amps? So we use the formula to find voltage. So the current is 2 amps, the resistance is 100 ohms, so we just multiply it out and we get 200 volts. In example 3.3, what we are solving for is using Ohm's law to solve for the value of the resistor once we have the voltage and the current. So right here we use the formula that is solved for the resistor. So voltage is 12.6 and current is 50 amps. So we divide, we get 0.84 ohms. They can also be written using the prefixes as 840 milliohms. Let's move to example 3.4. Right here it says, show that if the voltage is increased 3 times its value, then the current is going to triple. So notice this way that I'm not just writing what is the value of the resistor and what is the value of the voltage, but I'm drawing a basic circuit where I identify each of the quantities. So the voltage stays for the voltage source, I'm indicating the direction of the current, and I'm localizing the load, which is the resistance, and its value, which is 100 ohms. So I'm asking to show that if the voltage is increased 3 times, what happens to the current? We say they are directly proportional. So if the voltage is increased 3 times, we expect that the current is increased 3 times as long as we keep the resistance constant. So B1 is 10 volts. We solve for I. We get 0.1 amps. Now we triple the value of the voltage. We solve for the value of the current again, and we saw that it tripled as well. So right here it says, okay, what happens to I if R now it goes from being 100 ohms to 300 ohms and voltage is 3 volts? So we have current, it's equals to voltage over resistance. So we find the current. We find that it's 909 milliamps. But what happens if in this case the same setting, the voltage is kept constant, but the resistor now it goes down. It goes from 330 ohms to 270 ohms. We stated the definition, the mathematical relationship of Ohm's law with current and resistance as being inversely proportional. So we are assuming that if the resistor is decreasing, like in this case, the current should increase. So let's see if that happens. The voltage is 3V. Let's find current. That's the formula. 3 divided by 270, we get 11.11 milliamps. So yes, 11.11 is bigger than 909, so the current did increase. And we proved that the current increase, which is inversely proportional to the value of the resistor. In question number, in example 3.6, it says find the value of the current using finding it in milliamperes. Remember, chapter 3 is about Ohm's law, so when we find current, we are going to be using Ohm's law, not the definition of current. Okay, so again, I draw the circuit, I identify the voltage source, the resistor, and the closed path for the current to flow. If we don't have a closed path, the current cannot flow. There is nothing, there is no current here. So the value of the current is going to be 50 volts divided by 1000 ohms, which is 0.05. But we don't stop there. They are asking for the answer to be milliamperes, so we have to go from amperes to milliamperes. So we use this conversion factor. We know that 1 ampere has 1000 milliamperes. So the answer in milliamperes is 50 milliamperes. In example 3.7, they are asking us to do the same thing, with the difference that now they want the solution or the answer in microamperes. So again, we have different quantities, the same circuit, we are looking for current again. So we have 25 divided by 4.7 mega ohms. We replace the mega by its equivalent, which is 10 to the power of 6. We divide the 25 by 4.7, we get 5.32. We use the law of exponent. This is to the power of 0, and then this subtracts from 0, so we get 5.32 times 10 to the negative amperes. Then we replace the power of negative 6 by its representative, by its metric prefix, which is microampere. So this is the solution, the right solution in the right format they want it. In 3.8, they are asking how much current in microampere is there through a 100 mega ohm resistor when 50 kilovolt are applied across. So let's draw that. So I have the source, which is 50 kilovolts, pretty high, and then we have the resistor. It has to be pretty high in order for it to handle that voltage. So they want the answer in microamperes. So again, we have voltage source divided by the resistor, so 50 times power to the 3. We are replacing the K by its equivalent, and we are replacing the mega by its equivalent. So we divide the 50 by the 100, we get 0.5, and now we subtract 3 minus 6. So we are going to get 0.3 times 10 to the minus 3 amperes. They want microamperes, so we have to go from milliamperes, which is 10 to the negative 3 equivalent, into microamperes using this conversion factor. 1 milliampere is equivalent to 1000 microamperes, so we have the answer as being 500 microamperes. We move on. Now we are going to do example 3.9. In example 3.9, they want to know what is the voltage needed to produce a 5 ohm current. So we are looking for voltage. They are giving us the current needed, and they're giving us the value of the resistor. So we use the formula to find the voltage, which is just current times resistor. So we need 500 volts for us to produce 5 amps. In example 3.10, they are asking us to find the value of the resistor. What is the voltage drop across this resistor right here? In this case, there is nothing connected to the voltage source, so the voltage source has to consume, the resistor has to consume the voltage source. So we can use this fact, and remember, this is showing how we will place the voltmeter across the resistor for us to find out the voltage drop across this resistor. So voltage is resistance times current, so we just multiply that and we find out that it is 280 millivolts for us to have this current.